Let's see. Should I wear my hood up or down, do you think? This is hood up, you know? I could be like, have on my hoodie. I should be live now. Hopefully. Let me check everywhere. You know how I am. Oh, goodness. Are we live on, let's see, are we live? We are live on Periscope. Fantastic. All right, there we are. We're there. Sweet, guys. Let me see. We're on Periscope. Let me make certain we're on YouTube. Alrighty. Let me see. It's been kind of, hopefully it's not choppy. I didn't like putting like, hey, Andy. Let me go to my channel. It looks like you might be the only person here. So I have 3 watching. Yay. Hey, Nether. I have a new onesie, guys. Is it a onesie or is it a hoodie? We should just start playing that game, I think. Live on YouTube, right? Good morning. Good morning, guys. So I think I'm live everywhere. I always check, because technology sometimes is not my friend, and it acts really weird and stuff. So, yeah, let's see. Let me see if I can find. Am I live on Facebook? Yes, I am live on Facebook. Oh, cool, man. Let me get my little graphic there going. See, I try to bring interesting graphics. Good afternoon. Hello, everyone. So this is what won the poll last, and I didn't make a little trailer like I normally do because I was really late with my poll. I think I need to do my polls a lot sooner. So would you like to play it? Is it a onesie or is it a hoodie? Good morning, guys. So I thought, I've got my Black Panther mug. Quantum entanglement is really kind of cool and spooky and weird, but kind of cool too. I actually did, it's really funny. The thing that I like about my show, before I get started, the thing I like about my show is that my audience picks all the topics. So if you're new to this, my audience, viewers pick all of the topics, and then I put it together in a poll. If you're a patron, I just do a show on what you want. So if a patron's like, hey, I want you to do a show on this, freaking done, man. It works out that way. No bones, no skin off of my nose. But, if it's standard viewers, but they all pick what it is that they want me to talk about. And then we have a vote. And then after the vote, then I put on a show about it. So sometimes it's stuff that's outside of like my strong, because my knowledge is mostly like biology and chemistry and biochemistry and analytical chemistry and stuff like that. So when it's stuff like, and I love quantum, but I've gotten to learn a bit about quantum just from doing this show. I had to learn relativity really well. So it's like, just like last week. Yes, Andy, you picked that particular topic, which is awesome. So, for stuff like this, it gives me an opportunity to go through, and I have enough of a good knowledge base to be able to tackle a lot of stuff like this, because I've read a lot about quantum anyway. But stuff like this makes it really cool. So when my viewers are like, hey, can you talk about relativity? I'm like, oh my gosh, yes, I love relativity. That would be so cool. And then I have to kind of stretch my brain into areas that aren't, that haven't been like my research or stuff like that. So it's really awesome. So thanks for having quantum entanglement, because I've got to read a lot of cool stuff and learn a bit more about that. And in turn, I get to share it with you. So let's go ahead and get started. All right. So, Hemphill asks, are you still freezing over there? It's still cold. It's just cold. If it's like, I'm not like up in the polar vortex. I don't have my toilets freezing or anything like that. Fortunately, that's not where I'm at right now. So that's nice. So I really have absolutely no place to complain whatsoever compared to like Chicago and those places, because that's kind of like, oh my gosh, it's like deathly, horribly cold there right now. There's lots of scary things that are coming out in the news about that. So maybe I'll throw that in there and see if you guys want to know more about the polar vortex. Let me know and I'll put it in a poll. All right, so we are talking about quantum entanglement. So what am I going to talk about? All right, so we're going to talk about what is it? It's freaking what is it? What is quantum entanglement? What is the research? What have they been doing? What are the things that are associated with that where people are just like, what the heck is this? And how can it be useful? It actually has quite a few interesting uses. And I have a couple videos we're going to watch too, which is really kind of neat. So that'll be kind of cool. So here's the simple breakdown. This is like the most basic freaking breakdown I can find. Essentially what happens is two particles get connected. And one acts opposite to the other. Affecting one particle affects the other, and distance is essentially irrelevant. And so that's kind of what's cool about quantum entanglement. And what I kind of see with that, here, pop you over here so we can have the chat, should show up over here, hopefully. Is the chat there? Is the chat not there? Why isn't the chat there? Why is there no chat there? This is like my life. Chat, you should be there. I don't know why it's not there. Alright, so that kind of sucks. Anywho, I have had to update the chat recently, so it's not showing up on the side, so apologies for that. See, technology kind of sucks sometimes. So, but I can see your chat and I can still see your questions. So I have I have my Restream app right there. So that's kind of helpful with the chat. Anywho, so with the quantum entanglement thing, essentially it's kind of cool in how it goes because it kind of spins in opposite directions. And so you have particles. One particle will be spinning one way, and the other one is going to spin in the opposite direction. And so I'm going to talk a bit about how it is that they actually start spinning and how it is that they can become entangled, which is kind of weird. So Andy says, and I'm scrolling through the comments, and you can't see them because for whatever reason, OBS does not have my chat right here like it always does. There's always something somewhere that happens, and it's just like, not today, ScientistMel. We're just going to screw up all the technology stuff that you worked so hard to put together. So, so it's -20 where Hemphill is. Oh, that stinks. It's about 0 in the UK. You've had to close the window. Wow. It's 60 degrees Fahrenheit where Andy is. Australia is burning, and the US is freezing. That's what Nether says. Oh, you see the chat. Okay, so people see the chat. Maybe it just doesn't show up on my end. Okay, good. All right. And with wind chill. Wow. So, so today, quantum entanglement. Wouldn't it be cool if we managed to do something with photons? Quantum entanglement. But we know, oh God, it's just so weird. It's so freaking spooky. So how is it that particles can become entangled? So this is a pretty interesting question. Hello, soldier girl. Just a tiny bit of snow outside. All right. Okay, so you might be sitting here going, okay, how do particles become entangled? Because that was a question. That was a legit question. So when I was going through trying to get stuff together, and I'm like, okay, so particles can become entangled. Well, how can they become entangled? Well, they do that physically. Photons can become entangled by blasting them with a crystal and a laser to generate particles that connect with one another. Now, once they connect... Oh, okay, YouTube isn't showing the chat collection, just the YouTube chat. Okay, thank you. All right. So each individual, wherever you're streaming, if you're streaming on Periscope, you'll just see the Periscope chat. If you're on YouTube, you'll just see the YouTube chat. Apologies for that. Normally my chat pops up on my screen, but for whatever reason, OBS is acting kind of funny today. But, you know, it's not a live show unless something goes wrong. This is why it's some of the best Saturday Night Live shows are when the actors are laughing. Because that just means it's, you know, it shows a bit of, to me, it shows a bit of charm, and it makes the actors on the show quite relatable. You know what I mean? And touchable, you know? Yeah, they're putting on a show, but things go wrong sometimes, and it's just kind of fun when that happens. For me, at least. It gives it a sense of charm. So, back to particles and how they become entangled. Well, you can blast them with a laser through a crystal and generate particles that connect with one another. So once they connect, they gain similar properties but move in opposite directions. Now, the thing that's weird about quantum entanglement is that sometimes it goes against this idea that photons exist in all states, spinning in all directions, unless they are observed. So once they observe, they kind of pick which state that they're going to be in. So whatever state it's in, the opposite particle is going to be doing the opposite spin of that. So once particles become entangled, whatever you do to one, the other particle is going to respond in the opposite way. So it's kind of interesting in that regard. So I have this graphic that I thought was pretty cool from Live Science, and then a video in just a little bit from Science Daily about this. So this is kind of cool. Occasionally broken software. This is right. You're not incorrect about any of this. So let's take a look at this pretty cool graphic. So here, this graphic comes to us from Live Science. And so essentially what I got going on in this picture, it's kind of explaining how it is that particles become entangled. So when two particles, for instance photons are quantum particles, when they physically interact, and in this case by a laser, they become entangled. And so we have a picture of these two photons that are split into entangled photons, which is kind of cool. And so here we've got this laser, it's blasting through a crystal, it's got some entangled photons, and now they have similar properties. Now what happens here, no matter how far apart these particular photons are, they spin in opposite directions. So it doesn't really matter, and we're going to talk a little bit about what it is that science, about researchers have shown to be that this is the case. So they can be, gosh, China did one that was just, anyway, they've done it with quasars, they've done it with satellites. There's other tests, there's like the Bell loophole test, you know, so we'll get into all that in just a second. But first, two photons get entangled or one getting split. Well, you can make one split into two, into particles. And so that's usually how you do it. You can beam them that way. That's my understanding, is that you split the photon, it becomes two entangled particles. And this is actually inherently useful for quantum computing. And we're going to get into that in just a second. So that's how we actually get them entangled. So I have a video to kind of show us a little bit about what it is that they do. I'm going to put on my headphones so I can listen because I think it's a pretty cool video. This comes to us from Science News, and hopefully they won't just decide to shut me down in the middle of my live stream. So for this particular one, let's see. Here is this video.
The quantum world is a spooky place.
Quantum world.
A lot of that spookiness is due to something called entanglement. That's when two particles become mysteriously linked. When you measure some property, like spin, of one particle, you automatically know what the spin of its partner will be, even if that other particle is on the opposite side of the universe. Weird, right? Let's break it down. Imagine each particle is a coin. Spin those coins on a table.
I really
Will they land
like
heads
this.
or tails? You don't know. Similarly, a particle's spin is a mystery until you measure it. Now, let's assume these coins become entangled. They're still spinning. Finally, one lands. You see that it's heads. Now, you know that the other coin whenever it lands, will be tails. Guaranteed. The coins, or particles, aren't communicating. One doesn't call up the other one and tell it to land tails. Instead, they're like two parts of a whole, with a shared history and a mysterious, inexplicable cosmic connection. That's the magic of quantum entanglement. Physicists have been exploring how to use entangled particles to build powerful quantum computers and unbreakable ciphers. But now, some scientists think that such a long-distance connection has more fundamental importance. Quantum entanglement may serve as the thread that stitches space together. Researchers studying mathematical models of the universe have found that cutting the link between previously entangled particles is like tearing apart the fabric of space-time. So
That's
entanglement, a concept Einstein strongly disliked, may actually be the key to making his general theory of relativity jive with quantum theory.
So that comes to us from Science News. Hold on. All right. So that comes to us from Science News, which is pretty cool. I liked that particular video because of the fact that it's showing, you know, the coins are going to spin in opposite directions. And so we're going to talk a little bit about Bell's theorem, which is something that's actually kind of important. Yeah, quantum is a pain in the butt when you're trying to make things really small. This is true, boo, and hello. So what's kind of weird about this is that they still share these properties no matter how far apart they are. And so quantum is always kind of strange. It's kind of like the whole Schrodinger thing where you're sitting there and, you know, if you observe a photon, it exists in all states until you observe it and then it's spinning in a particular way, or you do that with a particle. So it's kind of interesting. And so we're going to get into a little bit about what it is, because how we measure things, are particles entangled or not. Just we might have things involved. There's something called the freedom of choice. You know, freedom is always a thing. So they're trying to close that loophole a little bit to show definitively that particles are entangled, or are they entangled because we just think they are, and maybe they aren't really. Maybe we're doing something to them to make them look entangled. And so it's really early in the morning for me. Well, it's not really early in the morning for me, but I'm still drinking my coffee, and it's just, I'm sitting here reading this quantum entanglement, and I'm sitting here going, wow, this just freaking blowing my mind every day. The existential, you know, dread just kind of sits in. It's like, what are you? It's hard not to have an existential crisis like every single day when you're reading cool stuff. Like, what does it all mean? So I try not to do that too much. So let's take a minute and talk a little bit about what we just saw. So the thing that I find interesting about quantum entanglement is that you can manipulate a system and affect the other and know what it's doing, you know, essentially, and know exactly what it's doing. But also, it will respond in the opposite way. So if it's spinning one way, you know the other one is spinning in an opposite way. So whatever you do to one system, it's going to do to another. Yeah, it'd be kind of difficult to measure a single photon's polarization. Yes, Niels Bohr, if you aren't deeply unsettled by quantum mechanics, then you don't understand it. And if you think you understand quantum mechanics, then you don't understand quantum mechanics. I think that's the other quote, I think. Yeah. So this particular riddle, this particular stuff, this quantum entanglement, it reminded me a bit of the door riddle from Labyrinth. I need more puppy time in the morning. Oh, my puppy is in his kennel right now because he's a little bit crazy in the mornings. He's decided to save us from everybody in our neighborhood by barking in the backyard at 7 o'clock in the morning. We let him out so he could go do his business, his morning business, and he was barking at 7 in the morning. Ugh. Oh, goodness. Somebody's talking about the Deadpool figure in Mel's right shoulder could be entangled with the goose over her left shoulder. Oh, gosh, man. So the thing that I find that's really interesting, oh gosh, I don't think I understand it. It's enough sometimes to acknowledge it true. You can't understand quantum physics. You just have to accept it. That's true, Soldier Girl. It's Feynman, I believe. God, it's crazy. So that entire clip, so that particular clip reminds me when I think of like quantum entanglement. One of the things there's different things that came to my mind, like how am I going to explain quantum entanglement in a good way? One thing that popped in my mind was like Dr. Seuss Thing 1 and Thing 2. You know, you had Cat in the Hat. Thing 1 and Thing 2 do the exact opposite of what you ask them to do. And so if you have particles that are entangled, you have one, you're manipulating it in a way, and you know it's reacting, or it's spinning in one way. You know the other particle is doing the opposite direction. It reminded me of Thing 1 and Thing 2 from Dr. Seuss. And so I'm like, that would be pretty interesting. But the other thing it kind of reminded me of, which I think is probably a bit more indicative of quantum, is the door riddle from Labyrinth, where one always lies and one always tells the truth. The entire clip reminds me of quantum in that as soon as you think you figured it out, you get something entirely new thrown at you. So it's kind of like, if you haven't seen it, I have the clip, but a part of me is kind of scared to play it on the live stream because YouTube is wildly notorious for shutting down my live streams where I have any kind of example where I'm talking about something science related, but I use it. Oh, Periscope was messing up. You switched to YouTube. Okay. So anytime I try to play a clip where I'm using it to give an example for like to discuss a science concept, YouTube almost immediately shuts me down and flags me for copyright violation. But I'm an educational channel. So I'm going to try to play the clip from Labyrinth, but what I want you to do is kind of go with me. When I watch this, I think of quantum because you have the guy, one who always lies and one who always tells the truth. Is rigged from the beginning. You can tell because one of the knights' names is the one explaining the rules. Yes. So you have one. It is. It's kind of rigged from the beginning, but it's kind of interesting. It's kind of interesting because when you get into Bell's theorem, and I'm going to talk about Bell's theorem in just a bit, where you talk about freedom of choice, if you remove degrees of freedom from what scientists are showing now, if you remove degrees of freedom and you remove the freedom of choice, if you let go of a bit of freedom of what settings you're choosing and you have it set random, the particles bust through the limit of detection. So according to Bell's theorem, you have a limit on how much you can detect on a reasonable with reasonable accuracy on determining whether or not particles are entangled. Because the more you do something, the more you frick around with something, the less likely it is to act in its native state. I mean, that's just kind of how it goes. And so if you remove some of that freedom of choice, you find that they act more real, and the realism in the locality, you know, behaving like with the speed of light, that's locality, and then you have realism with where it's spinning in a given state, where the particle chooses its state rather than you choosing it for it. It tends to bust that limit out. It just completely disregards Bell's limit. So it's pretty interesting. But I found like you said, I think it was Nether, I can't remember who said, but like you said, you know, if you establish, but that also brings apart the question of if you establish in advance what these certain settings are, if the universe, did the universe, when it was generated, establish specific natural settings that dictate how these particles are going to act? You know, so the knights that are standing at the door of the labyrinth, are they setting the settings in it? Are they giving that are giving the rules? Are they basically putting the settings in advance and how the particles are going to interact? It's just kind of like That's why it reminded me of that clip. So I'm going to try to play it and look at this clip from a quantum aspect, as you have one always lies and one always tells the truth. So in quantum, you have particles that spin in opposite directions. So if you get one and you try to get one and you're working with one, how do you know, the other way? It's just like, and then when she thinks she sorted it out, she hasn't. That's quantum, in my opinion, and I think a lot of others. So let's see if we can actually play this particular clip without me getting some kind of strike. Wrong one.
The quantum world.
Guys, let me know if YouTube goes nuts on this, and I'll...
Someone has been changing my marks. What a horrible place this is. It's not fair.
That's right. It's not fair.
Quantum. It's not fair.
This was a dead end a minute ago.
No, that's the dead end behind you.
It keeps changing. What am I supposed to do?
The only way out of here is to try one of these doors. One of them leads to the castle at the center of the labyrinth, and the other one leads to certain
This is quantum right here. Quantum. Boom.
Which one is which?
We can't tell you.
Why not?
We don't know.
But they do.
Oh, then I'll ask them.
No, you can't ask us. You
Jennifer Connelly, yes.
It's in the rules. And I should warn you that one of us always tells the truth, and one of us always lies.
Particles. They're spinning.
I do not. I tell the truth. Oh, what a lie.
Alright, answer yes or no. Would he tell me that this door leads to the castle?
Oh, goodness.
Yes?
Then the other door leads to the castle, and this door leads to certain death.
Man.
How do you know? He could tell the truth.
But then you wouldn't be. So if you told me he said yes, I know the answer is no.
But I could tell the truth.
But then he would be lying. So if you told me he said yes, I know the answer would still be no.
Wait a minute. Is that right? I don't know. I've never understood it.
No, it's right. I figured it out. I could never do it before.
Here we go.
It's getting harder.
Yay. Oh my goodness. The clip is more like Einstein's God does not play dice than quantum entanglement. I think okay, so Nether disagrees with me on the clip is more Einstein's God does not play dice than quantum. Well, to me, it made me, when I do stuff with quantum, when I'm sitting there and I'm reading quantum, it's just like, it reminds me a lot of that scenario. Because when you think you've figured out the answer, something entirely new kind of comes up and it just throws you through a loop. So the moment you think you understand it, you don't. And so for me, the one who lies and the one who tells the truth, to me, that was the example of them spinning in opposite directions. But the more she would manipulate with one, the other one still responded. That's what I took from that. But happy to disagree. But that was just, I like that clip because to me it's just like when I felt like when I started getting into learning about quantum, I felt a bit like Jennifer Connelly. I'm like, oh, okay, I sorted this out. And you're like, oh, no, you haven't. But, so it's just kind of weird. But yeah, that's from Labyrinth. And then it was just like, why is it always changing? And then now you get into chaos theory a little bit. You can kind of throw a bit of chaos theory. The more variables you have with a particular situation, the least likely you're able to predict it. That sort of thing. So it's weird. Gosh, I'm going to be thinking about this all day. Well, I always thought you just kind of I wrote my comment on the Twitter feed. Sorry. No, it's okay. Don't worry about it. It's all right. You know, if you have questions, you can always hit me up on Twitter. My physics professor said quantum physics only makes sense expressed in mathematics. All other languages fall short and cause confusion. That's entirely true. But there, you know, when we get into Bell's theorem, what does the bog, extending the labyrinth example, what does the bog of eternal stench represent at ScientistMel? Geez, man, I don't know. Maybe that is one of the older galaxies that are emitting a certain type of chemical that stinks from a weird portion of the universe. Maybe that's the bog of eternal stench. I guess QE could be an effect of one of those hidden dimensions that are proposed by some theories. Maybe, but I think the thing that is elusive is how is it that, I mean, what is that connection? Is it a thing? It's just like they don't communicate with one another, but they always act in opposite ways. So yeah, and here comes the existential dread again. I've often thought the universe only makes sense if you consider reality to be mathematics that just happens to have physical properties that we detect. True. And also, coming from a person who's been a science educator, I find that people have a hard time connecting science concepts to mathematics. And so what I often do is talk about the things that they already know, and then I introduce the math, because a lot of people have a real fear of math. And so having to, I kind of introduce the equation first without introducing the equation. And then I show this is how they interact with each other before I introduce the math. And then I bring the math in. And then that tends to go pretty well. Oh my goodness. So that's usually how I introduce when I go with math. Because people have a genuine, I would say there's a huge chunk of the population, at least the ones that I've interacted, that have a genuine fear of math. And so when I start introducing math, I do it in such a way to where I've already kind of discussed a bit about what the individual variables are, and then I go, okay, now this is how we translate that to math. When they already know how things interact, if they have an inverse relationship or not, you know. So is just walking delicately in eggshells, essentially, when you're dealing with math with the general population. Oh goodness. And so let me see, let's talk a little bit about the different things that have been confirmed. And I use that term loosely, so let's keep that in mind. When I say confirmed, I don't mean that it's like completely total canon. So some things that are kind of cool about what's going on with quantum physics, as far as quantum entanglement. We've got China in 2017. They used satellites with entangling photons in order to show that they could do that. And I'm going to talk a bit about that. You also have the Bell loophole that has been kind of overcome with various experiments, starting from the early 2000s up through, I think, last year. And then there's also distant quasars that they've used to kind of confirm entanglement by reducing that degrees of freedom. I kind of talked about the freedom of choice. You usually have bizarre math nightmares when I have high fewer. One time I was in a medieval castle being besieged by geometric shapes. Oh my goodness. So what's kind of cool about, and I like this particular GIF image here because it kind of shows if you're doing one thing to one, the other one's going to be the opposite in that. But it's kind of, So I have various sources for this, and I'll show them to you at the end. I've been looking around. Quantum Magazine is a really good magazine to that gets into it's it gets into heavier discussion about quantum physics and that sort of thing, but it's still readily accessible for an avid reader of physics, which I found to be quite good. Scientific American, they have a really good article about the China satellite. Space.com and Astronomy.com have really good articles associated with how they've been doing quantum in space, which is kind of neat. Andy, you coming to the party tonight? Is there a party tonight? You guys are going to a party and you're talking about it on my channel and you're not even inviting me. Golly, how rude. Picking on you guys. Oh, goodness. All right, so let's talk a little bit about China. The results from the MISSIUS, I think it's MISSIUS or MISSIUS, I'm not certain, satellite test with the quantum entanglement, essentially they point the way towards what some would consider a hack-proof global communication. So scientists in China involved in a landmark study in 2017, they showed that entangled particles separated by 1,200 kilometers could be measured to show that entanglement exists between these particles. Now, this is leading a movement towards a quantum internet, which many say would be unhackable. Now, the reason for this is that if you alter the state of one particle, it would leave an imprint and be easily detected in the other. While ground-based quantum computing involves entangled particles, they can crash with other atoms and disrupt their states, which then limits how far they could conceivably travel, without being altered. So quantum computing is highly desirable with this spooky action from entangled particles at a distance, as hackers would be easily traced, which would be kind of cool. Let's see. I'm trying to catch up on people if they have questions. If you fail my physics exam 3 times, you should get a theology degree for free. Oh my goodness. Nether is due for fractal nightmares. Unhackable computing will never happen because the NSA and others demand backdoors. Well, the thing is they would be detected that something had changed. There would be something that changed between the two signals. So that's kind of what they're going with that. But, hey. Let's see. Messages would be able to be intercepted, but that would be detected on the other end. So I guess unhackable is kind of like a relative term. Yeah, China is investing a lot into quantum encryption. All right, so the Bell loophole. Now, let's talk about that. This is one that scientists had to deal with in order to overcome quantum rules in locality, realism, and freedom. Now, locality is pretty much associated with the speed of light. Realism relates to the states of the particles, and freedom deals with choice. Now, John Bell, he was a Northern Irish physicist who derived a theorem involving these particular variables. Now, some research that was going back in the early 2000s, Massachusetts Institute of Technology, found that you can keep locality and realism by giving up just a little bit of freedom. Now, Bell's theorem puts a limit on how often in a local realistic universe 2 entangled photons could be detected. So this becomes a problem. The whole idea is that the more you have, like if you're trying to manipulate settings, it becomes a bit more of a problem that are they actually entangled, or is that just what they're doing right now? So what the researchers at this particular institute found that entangled photons correlate more often than what Bell would limit. Their experiments involved modulators that had different polarizing directions. So that means if it was polarizing a photon on one end to spin one way, then it can manipulate which way it was spinning. Now, they removed the freedom of choice and generated random settings. Now, by removing this freedom of choice, they found that the particles correlated more often. Now, more research has since occurred and confirmed that giving up a little bit of this freedom breaks Bell's limit. Oh, movie night is tonight. Okay. goodness. Oh, people sending me messages. I see your messages. And thank you. All right. So, another example. Oh goodness, maybe I'll swing by at movie night. I have been sick most of this week, and I had to go to the doctor and get a shot. I might swing by movie night tonight if I can. It's just so late usually for me, and I get up really, really early during the week, and I have been like really just icky sick this week, but I'm okay now. Got a shot. Antibiotics, woohoo. All right, so another example when we're talking about quantum entanglement is given up the freedom of choice. Scientists left it to the universe to decide by having quasars choose which properties of entangled particles to measure. Now just kind of recap again with the freedom of choice loophole that I mentioned just a little bit ago. It states a hidden classical variable can influence how an experimenter decides to measure seemingly entangled particles. So if they look like they're entangled. Now this can give what is essentially a false appearance that particles are tangled when they're not. So astronomy.com kind of reported on this particular experiment. Okay, so sorry, somebody's trying to call me right now. Astronomy.com reported on this. Now, the study went a little bit like this involving the quasars. They essentially used two 4-meter wide telescopes. They used the William Herschel telescope and the Telescopio Nazionale Galileo, which happens to be in Spain. And I'm certain I butchered that name, so I'm apologizing now. Now they're located just they're located just over half a mile, about a kilometer apart. Both telescopes were trained to look at different quasars that were billions of lights apart from each other, or billions of light years away from each other. Now, there was a station that was placed between them, and at this station, researchers beamed entangled photons, one member of each pair, to a detector at each telescope. Now, as these particular entangled photons traveled to the detectors, the telescopes analyzed light from the quasars and determined whether the light was more red or more blue than the baseline. So, in essence, depending on the measurement, these entangled photon detectors automatically adjusted their angles of their polarizers, which are these devices that measure the spin of the photons, also known as the photon electric fields. Now, this allowed the researchers to test the photon pairs if they were truly linked to one another or not. So over the course of this 2 15-minute experiments, they used two different pairs of quasars. The researchers measured over 17,000 and 12,000 pairs of entangled photons, respectively. Now, with this study, the results show it's extremely unlikely a classical mechanism is responsible for the strong correlation observed between the photon pairs, meaning that these were entangled quantumly. So this is pretty interesting with that. So that's one way they removed the freedom of choice loophole to kind of show that these were actually entangled. So there's more and more research that's going to kind of show that we do have confirmation of quantum entanglement, which is kind of cool. So, oh, we got people talking about that. Let's see. Woohoo! All right. So, it's recently been brought to focus on whether mind was in the universe before matter. Well, here's the thing about that. When we get into we know that certain settings can affect how particles react. So it's kind of interesting to think, okay, what settings were involved in advance? Did the universe dictate the settings at the beginning, or are the settings kind of changing? So it's kind of like, how did, it's just like, I don't know, man. I don't know. They did allow it as long as we were able to show full understanding. Oh, okay. So you're talking about calculators in your class. So yeah, so it's kind of like one of those things. When the universe started, like with the Big Bang, were these settings already put into place at that moment? Was that when these settings were dictated on how these particles would interact with one another, like with the entanglement? Do particles have a memory function? They act like each other. And they're like two opposites of a whole. And so they only have interaction. Well, they only have memory of the other. I would say if memory is a thing, they retain the characteristics and traits of the other particle, but in the opposite direction, if that makes sense, where it's spinning and stuff. And so if one particle is spinning one way, the other one's spinning in the opposite way. And so if you mean memory in regard to characteristics and traits, they're like two sides of a whole. So there's that. But I don't know that you can make one change, but only if you're altering the other one. If that makes sense. But they don't talk to each other. So it's weird. It's just weird. It's really weird. Why isn't it possible to use the double slit experiment to send messages to the future? Double slit experiment to send messages to the future. Well, I mean, they've done a lot of research about trying to do that, but to me, I don't believe in time travel. To me, I don't believe in time travel. And so I don't think it's possible to go into the future or to the past. Because to me, in our sense of time, it's a human construct in how we organize our lives. I think it's possible we might have other dimensions. And it might be, if we figured that out, we might can communicate with those. But I don't think it's, I don't think it's we can travel within our own timelines, but maybe talk to other dimensions. The double slit results are still random, so you can send messages, but they amount to only static. Well, I don't know if I agree with all of that. I'd love to send the Bitcoin charts of last year to myself in 2009. We go into the future constantly. Yes, I'm constantly moving in the future, like right now. Here, too. Right now. Yeah. Yes, there's no way to code something into entanglement without breaking the entanglement. Yes, that's true. You would alter it. Yeah. Oh, goodness. Why do we want time travel? When we want it, it's relevant. Oh, my goodness. Oh, this is too much. It's too much. And it's almost 11 a.m. Oh, goodness. So, kind of just wrapping up a little bit here. Ah, gosh. You guys are funny. So, kind of like wrapping it up a bit. Quantum is spooky and weird. Particles are connected throughout the universe. It has applications in quantum computing, and much is still being learned about this. So this is what's kind of weird about this. And we've kind of talked a bit about what is it, what is the research, and how it can be useful. That's essentially what we've been doing this particular episode. Can particles change themselves by accumulating data around them through evolution? So I don't know that that's how it would work, Jorge, because we're talking about quantum particles, and when we're dealing with their characteristics, we're talking about their speed and their spin. It's not really something to where they're holding data, so to speak. No faster than light communications. That's correct. Time traveling got us those darn reboot movies. How did something come out of nothing? I don't quite know what you mean there. So, but I have to, if you're interested in the Big Bang, I have done an episode of my show on the Big Bang. You can check it out on youtube.com/ScientistMel. If you're watching on YouTube, you're already here. If you're watching on Periscope, I do all of my videos are there, but there's no way for me to organize them. So if you want to, you can hop over to YouTube and watch my show on the Big Bang. There's no such thing as time. Everything is happening simultaneously. Yes. I have a plate from a double slit experiment. Oh, goodness. So, quantum entanglement was really fun, guys. You guys are pretty cool with picking your topics and what you vote on. Hey, everyone. How are you guys doing? I'm going to take a moment to thank my patrons on patreon.com. So, let me adjust my stuff here. So, I'm going to take a moment to thank all my awesome patrons because they help me keep the lights on. James, Jen, Carl, Melanie, Patrick, Daniel, Stephen, Paula, Carrie, Cersei, Keith, Duke, James, NANA, thank you, Andy, Zachary, Tony, Bo, Stephen, Sarah, Chris, Graham, Dragnot, Godless Iowan, Jennifer, Richard, Doc Fearsome, and Neil. Thank you so much for all your contributions. It's mostly me who does this, and I rely heavily on the support and kindness of others in order to get accurate science content out for the masses. Teachers now are requesting content from me. So the things that you guys help contribute, I actually have teachers now asking me to make content for them, and I'm doing it. And so this is a lot of outreach. I do outreach for schools now in the form of helping teachers. I also make content for adults, and I'm working on more outreach content to hit the adult realm because we're really struggling with science communication right now when it comes to the science literacy. So thank you to my patrons. I do most of this myself. I do have friends that help me. Gonna go for it. Peter, he does a lot of, he does my intros. My friend Darnak runs my Facebook page. I have art from Livid Unum as well as Organized Chaos that I put on Patreon for my patrons there. They make art inspired from my work. And so, thank you. I do what I can. And your contributions help me have my website. I write articles on ScientistMel.com. And so everywhere that you can find me, you can find me on ScientistMel.com, Patreon.com/ScientistMel, Periscope, YouTube, Facebook. I'm also on Twitch. It's okay. So, if you have any topics you want me to do for the show, you can find me anywhere on these things. And I'm currently, so just really quickly, I'm going to show you my sources really quickly, and then I'm going to talk to you about a new project I'm doing. ScienceDaily.com, Quantum Entanglement, Astronomy.com, Scientific American, Quantum Magazine, Science News, and Live Science all have amazing stuff. So on their links, and you can go to my website ScientistMel.com, and I'm uploading these all of my slides for my shows on there. So if you want to use them in your classrooms or dig down a bit further, you are welcome to do that. And so yes. So I want to talk to you guys. I recently got accepted into a Facebook group on anti-vaxxers. So I'm going to do a little piece. I think I'm going to do a written piece and maybe have a little section on my show This Week in BS with Katie Paulson. I'm trying to get with her to see how often she wants to do that show. So hopefully I'll know soon to where we'll have a segment on This Week in Anti-Vaxxers and then talk about different things that I've found there. So that'll be pretty interesting. And I still would like to do ScientistMel Talks to Kent Hovind. So I think I'm probably going to make that like a couple times a month. I'll give Kent Hovind a call and ask him questions just out of sheer curiosity. And then later on talk about the inaccuracies in that particular exchange. But I won't be disrespectful about it. So you're welcome. Those are all pretty cool sources. But, you know, if you want to, I don't need this right now, my headphones. But if you want to, you can check out ScientistMel.com/resources, and you'll be able to find all of my slides from the shows that I've done. And so they're all there for you to use, peruse, and everything. There might be a new show as well. Yes! I am working with Andy from Sunday Science to possibly merge an idea that I have called Science Sunday School with his Sunday Science show. And then we will have the latest and greatest in science tech. So I have This Week in BS, but we will also have all of the new stuff coming out with science, tech, engineering, and math on that. So it would be Science Sunday School. So that's a new show that could be happening as well with Andy from Sunday Science. He might be on Sci Strikes movie night tonight, and you can find me there periodically as well. So I'm going to have a little shout out for different shows that I've been involved with. Hannibal and Monty's show. you from time to time, usually I have a segment on there, and I post my segments here for their show that they do related to a particular topic that they're discussing. I missed this past week because I was sick. But you can find me on their show as well. Hop around from time to time. Sometimes you'll find me on the Geek Room. Sometimes you'll find me on Godless Iowans channel. Been on Non Sequitur a couple times. You know, and I've been on Dear Mr. Atheist a few times. But you know what? You can find me around different places. And I'm talking to a local newsman about being interviewed for some of the work that I do online, like as far as with my science communicator stuff. So we're talking about setting up an interview soon. So it's all pretty exciting. I just don't openly talk about everything, but the help and support that I get from viewers, patrons, and the different intros and stuff that people send me that help me put together stuff, it actually is making a difference. And so I've hopped around on different places, and you can find me in all kinds of different places spreading the good news of science. So I'll let you know about the local news guy with the science interview, and I'm hoping this summer to be able to travel a bit more. I have been traveling a bit more, trying to do more outreach in different towns. So hopefully this summer I'll be able to do more of that. So if you want me to come to your town, let me know. I have the means to where I can travel and get to you, then I'll do the best that I can. And we can have a talk and do a show there. Maybe one of my spirited science shows, This Week in BS, Science Sunday School, or just a standard The Science Of at your local coffee place. And we can sit there and talk science and incorporate the locals and people there. Maybe even do a fundraiser for a school. I want to do a bit more of that as well. Try to raise money for research. For different things, as well as possibly, maybe raise some money for local schools and stuff. So, Denver, bring it on, sure. So, hit me up anywhere, ScientistMel.com. I'm also on Twitter. I'm on Facebook. You can find me just about anywhere. Just type in ScientistMel. And you can email me through my website as well. All right. This has been awesome, guys. I will put a poll up today so I can get my trailers out sooner. And I'm going to be on, actually on Monday. I'm on somebody's channel on Monday, so let me give them a little shout out. I missed his show. I was supposed to be on his show, Christopher Mott. I will be on his show Monday at 7 Eastern, 6 Central. So, there you go. 21 people here. There should be more thumbs up. Yes! Like, share, and subscribe my stuff, guys. Apparently, YouTube is being really weird, and people who subscribe to me don't get notifications that I'm live because you have to actually go and look at your notifications regularly, and you have to go and watch some of my shows. They won't just automatically let you know that I'm live now. So, that's kind of crappy on YouTube's part, but what can you do? And I just recently got monetization, guys, so thank you. And so I'm going to sign off here. I will be bringing back ScientistMel 24/7. I want to tweak it a little bit and put in some new content. So you can have live, it's pre-recorded shows, but it's all pieced together according to topic. And so you'll be able to check that out anytime you want. If you just want to pop in and put in your 2 cents and interact with each other. That's the whole point of 24/7. Hey, ScientistMel 24/7 is on my shows. It says live streaming, but it's pre-recorded shows. But you'll be able to interact with each other and have like discussions about what's going on. So that'd be kind of cool. I'm going to bring that back soon. I want to add more shows to it and make certain that's a good go for that. All right. Well, thank you guys for being here. Is it a hoodie or a onesie? I'm just going to let you guys, that's the new game, isn't it? Because it's cold outside. So, I'm going to end with Mr. Rogers. Thank you so much, guys. This is fun. You always make each day special for me. You know how? By just your being you. Sending squishy science hugs and have a fantastic weekend.